Okay guys, what I'd like to do now is start with distance on the coordinate plane. Now, just before that, we're going to do a quick recap of how to use Pythagoras' theorem to find a hypotenuse, because this is going to be useful to you. So let's say that we have a triangle, looks like this. It's a right-angled triangle. We'll make this side, say, 10 centimeters. This side can be 4 centimeters. And this side is going to be x centimeters. Okay? Now, in this case, we haven't got letters given on our triangle, so let's make some. We'll make it P, Q, and R. All right, which means our sides are going to be labeled as, remember the side is labeled opposite its angle, so this side opposite P is going to be side P, this side opposite Q is going to be side Q, and the side opposite R is going to be side R. Okay, I'm going to erase all that stuff in the middle. Okay, so we have this triangle. We have this triangle, okay, and using Pythagoras' theorem, we know that normally a squared plus b squared equals c squared. And remember, c must be the hypotenuse. Now in this case, the hypotenuse is q, so we're going to put q squared in for the hypotenuse is equal to, and for the other two it doesn't matter the order, so we'll say p squared plus r squared. Okay, now we can substitute our values. So instead of p, we're going to write 10. So 10 squared plus, instead of r, we have 4. So 4 squared is equal to q squared. Okay, 10 squared we know is 100. Plus 4 fours are 16 is equal to q squared. Okay, so we have q squared. Let's flip it around now. Q squared equals 116. Okay, therefore Q is going to be just the square root of 116. Now I'm going to type that in on my calculator. I have a nice fancy one. I can do it on the screen. Okay, so we have okay, so we have the square root of 116. Okay, and we want this as a decimal, not as a square root. Okay, because it's a distance, so we don't usually write a measurement in root form. So it's going to be Q is approximately equal to 10.77 centimeters. Okay, and there we go. So this is how you find the length of the hypotenuse in a triangle. We did this last lesson. All right, what we're going to do now is we're going to look at the coordinate plane. So let's say that we have a coordinate plane. We're going to work just in the positive area for the moment, just to make it a little more straightforward. Oops, that was not a straight line. Okay, so this is our coordinate plane that we're working with. Okay, let's say that we have a line that goes from, or let's say we have a point here. This is going to be, I want this to be on the line. Let's just assume it's on the line there. Okay, so let's say that this is point 22. Okay, and then we have a point somewhere up, let's say here, and this point is going to be 1, 2, 3, 4, 5, 6. So, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this is 10, 6. All right. Now let's say that I want to know the distance between these 2 points. Okay, I want to know how far apart these 2 points are. Okay, so what I'm going to do is I'm going to draw a line in between these 2 points. going to draw a straight line in between these 2 points. Okay, so we have this nice line here. Now we can use Pythagoras' theorem to find the distance between these 2 points, because what we can do is we can turn this into a nice right angled triangle. So if I draw a line down here like this, and then another line across from here to here, and what you can see is, again, we have a nice right angled triangle. Okay, and we can now use this. Now you know then that this point down here is going to be, it's 10 across and it's 2 up. So it's 10, 2. All right. Now when you have a situation like this, the first thing you need to do is you need to think about the distances on the sides. Okay, so those shorter sides, we need to know their distances. So this here on the right, this vertical line, you can see is 4 squares. So this is going to be a distance of 4. This line along the bottom is 10 minus 2, which gives us a distance of 8. And then the distance we were trying to find, the distance between them, that's our hypotenuse. So that's our C. Okay, so again, let's start with our formula. So we know that for a squared plus b squared equals c squared. Okay, doesn't matter which one a and b are, so we can just say 8 squared plus 4 squared equals c squared. Okay, 8 squared is 64 plus 4 squared is 16 is equal to c squared. Okay, and 64 plus 16 is equal to 80, so we have c squared is equal to 80. Okay, and you'll notice I flipped it there. It doesn't matter if you flip it here or if you flip it at the end, but we should always remember that we want the variable to be on the left at the end. So this is usually a good point to flip them around. Okay, so we have c squared is equal to 80. Take the square root of both sides, we get c is equal to the square root of 80. Okay, and again, on my calculator, if we take the square root of 80, square root of 80, okay, make it a decimal, then we get 8.94. So C is approximately equal to 8.94. And that's it. Okay, so this is how we find distances when it's on the coordinate plane. Okay, it doesn't really get much harder than this. Okay, sometimes you might have to do more than one distance. Okay, you might have to do more than one line, but that's really it. Okay, good luck.